3.7. We are going to be studying applications of solving for your variable, and your variable is in the exponent. Okay, this is the formula that we are going to use for the first problems. Okay, this is called the exponential growth formula. Okay, so what this is showing is if something is continuously growing or compounded continuously, that's when we're going to use this E in our formula. Okay, here is what the different things of the formula stand for. P of T, that's going to be your ending amount. Okay, these things will make more sense after we work one of the problems. Okay, this P with the little zero, that's going to be your initial amount, what you are starting with, whether it be money or starting population or starting anything. That's going to be the amount that you are starting with. The K, just like always, is going to be the rate in decimal form. Oops. Okay, sorry about that. So now the rate in decimal form is your K. The T is the number of years after the starting time. Okay, so we're going to use this formula to work these first few problems. Okay, number one has several parts to it. So let's write down what we know about number one. All right, it says in 2012, the population of a city was 6.48 million. So in 2012, the population of a city was 6.48 million. The exponential growth rate was 3.57% per year. So remember, anytime we're talking about the K or the rate, we want to first of all, I know I'm going to need that in decimal form, right? So I'm going to move my decimal 2 places to the left, fill in this missing hole with a 0. So my K is going to be 0.0357. So the first thing it's going to want me to do is find the exponential growth function. So let's see, and it actually has P of T equals blank. So it wants you to come up with this growth function using the information that you know. So remember, this P with the little 0, that's your initial starting amount, whether it's money, people, anything. So in 2012, it's saying the population was 6.48 million. That's your starting number. That's where we're going to be starting from. So 6.48 is your starting. E, that's the E number that we've talked about before on your calculator. So it's just part of the formula. Your K, I do know that, it's 0.0357. I do not know the T, right? This right here is the formula that you're going to use to answer the first part of these. Okay, so that's going to be my formula. That's the answer to the A part of this problem. Okay, the second part, the B, says the population of the city in 2018. So now in 2018, what does T stand for? I'm trying to find the ending population. So I'm going to find this number right here, the ending amount. of the population in 2018. Remember what T stands for? The number of years after the starting date. So in 2018, how many years is that after the starting date? 6 years. So I'm going to put a 6 in this spot, or in other words, I'm going to replace the T in the formula with 6. So I'm essentially finding P of 6. So replace the T with 6, so you have 6.48 E to the 0.0357 times 6. And we'll put that in our calculator. So in your calculator, you're going to type in exactly what you see. So 6.48. Now, remember where your E is. It's the second button and then the LN, right? Because E to the X is that blue. So second, LN. Now, that E, if you have the TI-84, it's going to go ahead and put you up into the exponent. So type in exactly what your exponent says. 0.0357, just like it says, open parentheses, 6, close. Hit enter. So what does this say? The population of the city in 2018 is blank million, round to 1 decimal place as needed. So there's the 8.02. So if I round that to 1 decimal place, it's just going to be 8.0 or just 8. It should take either one of those. So again, when it told me 2018, that meant I knew that it was 6 years after the starting date, which means I could replace my T with a 6. The C part says the population will be 10 million. So what we have found, let's make a little chart. So in 2012, it was 6.48 million. In 2018, it was 8 million. Now it wants to know the population of the city will be 10 million. So 10 million in how many years? So now I don't know the number of years. I don't know T. So let's replace what we do know in our formula. So do I know the end amount this time? Yeah, I do know. It's 10 million. So I do know the end amount. I still know the beginning amount, right? It told me that in the wording of the problem. E, I still know the rate, right? It's always the same, 0.0357. I do not know T. That's what I'm looking for, is how many years after 2012 will the population be 10 million? So I plugged in everything I knew. Look what you're solving for. The T, right? It's in the exponent. This is why we learned how to do those log rules, right? Logging both sides is what's going to pull your exponent down to in front of the term it's being raised to. So first things first, though, I'm going to get rid of the 6.48. So since it's times E, I'm just going to divide by it. Hang with me. So the 6.48s are canceled here. I still have E to the 0.0357T. Over here, just leave it just like this. Okay, I'm going to show you in a minute. We can just work the whole thing out here in a little bit in our calculator. So just leave this fraction just like it is, 10 over 6.48. Now, I am going to, since it's an E, instead of logging both sides, remember that's an ln situation, right? Log base E. So we're going to ln, if I do it to this side, I'm going to do it to this side. Why did I decide to ln both sides? Because now I can use that property of logs that says you can bring your exponent down in front of the term. So now on the right side, what do you have? I brought my exponent down, so 0.0357t times, right? It makes it times this ln E. But remember, what is ln E equal to? Just equal to 1, which means I don't need it. So all I have on this side is 0.0357t. On the left, again, I'm just going to bring this down. ln of 10 over 6.48. If I'm trying to get t by itself, all I have left is this 0.0357 hooked onto it, so divide by that. 0.0357. So that's canceled. So now look, all you have left on the right is a t. So now I just need to, now is when I'm just going to do all that in my calculator now. Now here's the deal. Make sure when you are typing this in your calculator, the only thing you're taking the ln of is that numerator, right? Not this. This came over after I ln'd both sides. So when you're typing in, you're going to do ln, and it'll automatically give you that open. You'll do 10 divided by 6.48. That's where you'll close it. And then hit enter and then hit divided by 0.0357. So again, ln, so just your regular ln of 10 divided by 6.48 and then close it. Go ahead and hit enter. Now you should have 0.43386 in your calculator. You're going to just divide, hit divided by your denominator, 0.0357. And hit enter. So the population of the city will be 10 million in about blank years after 2012. Round to 1 decimal place as needed. So since I have 12.15, that means I need to round this to what? 12.2. Since it was 12.15. The 5 told me to round that 1 up to a 2. Okay? Now, the last part of this question, the D, says the doubling time. When you are finding the doubling time of anything, it has this very specific formula. Whether you're talking about population doubling or your money doubling or anything doubling, it's going to be T, that's going to be the doubling time, is going to be equal to ln2 over whatever the rate is. So if you know the rate at something is growing, which we do on this one, right? Remember it was 0.0357. We're still on the same problem, so it's still the same rate it told me in the very beginning. Then I'll just plug that in for the K. So the doubling time is going to be equal to ln2 divided by 0.0357. And you'll just type that in your calculator. Make sure you put the closed parenthesis after the 2. So ln 2, close it, then divided by 0.0357. Hit enter, And the doubling time is about blank years, round to 1 decimal place. So since I have 19.41, I don't need to round up to 4, right? So the doubling time is 19.4 years. So if the population is growing at 3.57% per year, it's going to take it 19.4 years to double. All right, number 2. So that's the doubling time. So as long as we know the rate, we can figure out the doubling time. You can also figure out the doubling time if you know the rate. I mean, other way around. You can figure out the rate if you know the doubling time. That's the formula for that. The rate is going to be equal to ln2 over the doubling time. So on number 2, it's going to have a chart. It's going to be dealing with population again, and it's going to have 2 countries, country A and country B. And for country A, it's going to tell me the growth rate is 2.7% per year, and it's going to ask me to find the doubling time. For country B, it tells me the doubling time takes it 29 years to double. What was the rate that made that occur? So, using these formulas, let's do country A first. I know the rate. If I'm looking for the doubling time, I'm just going to put the rate right here. So the doubling time is going to be equal to ln of 2 over the rate. Now make sure you turn it to decimal form, right? So if I move my decimal 1, 2 places to the left, I'll have 0.027. Put that in your calculator. That's going to give you the doubling time. So I've got ln 2. Now again, make sure you close your 2 and then divide it by the rate. So divide it by 0.027, and it wants to round doubling time to the nearest whole number. So if I have 25.6 and round 25.6 to the nearest whole number, it'll be 26 years. So if the rate is growing at 2.7%, it's going to take 26 years in order for the population to double. All right, now let's figure out what country B's rate is. So if I know the rate, if I know the doubling time, it's telling me it took 29 years to double. Then I can put that number here in place of the T, which will give me this K, which is the rate. So the rate is equal to ln 2 over the doubling time. The doubling time was 29 years. So let's put this in our calculator. So again, ln 2 divided by 29 this time. And I'll just write this out several decimal places, and then I'll see how it wants me to write it. 0.0239016. I'll just go out there. Okay, it wants me to round growth rate to the nearest tenth. So first of all, it has this. First thing I need to do is turn this into a percentage and then round that percentage to the nearest tenth. So if I'm going from decimal to percent, 2 places to the right. So now I have 2.39016. Now I round it to the nearest tenth. So what's going to be 3, 9. The 9 rounds that 3 up to a 4. So 2.4 would have been the growth rate. All right, number 3 is another multi-part. This one has to do with investing money that is compounded continuously. Remember the other section that we worked with that talked about investing money? The formula was a little different. It didn't have that E. It had the N's in it, that 1 plus K over N to the NT, but that's when it told you it was compounded either quarterly or biannually, and those are the numbers that you put in for the N. If your money is being compounded continuously, that's when you use this formula with the E in it. So let's see what information it gives me. It says, suppose that $17,473 is invested at an interest rate of 5.9% per year. And compounded continuously. Find the exponential function that describes the amount in the account after time t in years. So I don't know the t. If I don't know t, I still have p of t. Because what is the p with the little 0 mean? That's your starting amount. Remember, it can be whatever you're talking about, population, money, anything. It is your starting amount. Well, what is the starting amount that you had invested? 17,473. The E from the formula. Do I know K? Well, here's my K. That's the rate, right? I just need to turn it to a decimal, which means move its decimal 2 places to the left and plug in a 0 in the hole. So 0.059 T. Okay, so that's what you're going to put in that first blank, the actual formula that you're going to be using. P of T equals 17,473 E to the 0.059 T. Now, the next 1, 2, 3, 4 blanks are asking you how much money do you have after a certain amount of years. So it's going to give you an amount of years now, which means on all of these, I'm going to know what the T is. The first blank says the balance after 1 year. Well, 1 year means that your T is 1. So you're finding P of 1. So 17,473 E to the 0.059 times 1. Type that in your calculator, exactly how you see it. So 17,473. Now remember where your E is. It's right above the LN. So I need to hit second LN. So there's your E. If you have the TI-84, it already puts you up into the exponent. If you've got an 83, you may need to push the up arrow to get up into the exponent. But this is exactly what you type in the exponent. 0.059, open parenthesis, 1, close. Hit enter, round it to 2 decimal places. So after the decimal, I have 925. So since that's a 5, I'm going to round that up to 93 after the decimal. So I've got 18,534 and 93 cents. The next question says, what's your balance after 2 years? So what is the only thing you're changing? typing the same exact thing in your calculator. You're just putting a 2 up in the exponents. So 17,473. Second ln for the e. Up in your exponent, 0.059. Open parentheses, 2, close. Enter. Round it to 2 spaces. So 0.390, which means your 39 just stays 39. It doesn't need to round up. So after 2 years, you've got 19,661 and 39 cents. Okay, I'm going to skip the 5 years and 10 years, just so we can make sure we can get through the end of this. But all you would do for 5 years and 10 years is what? Change this to 5, type it in your calculator, get your answer, and then change it to 10. Type it in your calculator and get your answer. So exactly the same way I did for 1 year and 2 years, just for 5 and 10. Okay, the very last part of this problem wants to know the doubling time, or how long is it going to be before I double my money? So remember, doubling time is always ln2 over whatever the rate is. And what's your rate? 0.059. So again, ln2, always make sure you close out that 2. Then divided by 0.059. And round to 1 decimal place as needed. So the doubling time, since it's 0.74, if I'm going 1 decimal place, I'm just going to be 11.7 years. Okay, so if you put that money in and it was compounded continuously at the rate of 5.9%, it's going to be 11.7 years before the amount doubles. Okay, number 4. On number 4, now we are talking about exponential decay, or in other words, now we're going down. We're not growing, we are reducing. Because the data in this table shows that the percentage of adults in a country who are currently married is declining, so going down. Assuming that the percentage of adults who are married will continue to decrease, according to the exponential decay model, complete the parts. So when you're talking about exponential decay instead of exponential growth, they use M's instead of P's. Also, what would make you go down instead of going up? Your K is going to have a negative in front of it. That's what's going to make you decay instead of grow. Okay, here's the chart, and we actually just need the beginning and the end. The year, and the percent of adults who are married. So I'm just going to type in percent married. In 1960, 70.5% of adults were married. And there's some other numbers. And then in 2012, only 41.4% of adults are married. The first thing it wants us to find is the K. This number right here. So let's see. Do we know the ending amount? Yeah, the beginning amount is 70.5. That's how many were married at the beginning. How many were married at the end is 41.4. So the beginning amount the ending amount, which is always right here, just like the other formula. What's on the left side of your equal sign is always your ending amount. So my ending amount is 41.4. What does this always stand for? Your beginning amount. So what was your beginning amount? 70.5. E, I don't know what the rate is. That's what I'm looking for. I do know what the T is. What does the T stand for? The amount of years it took to get from the beginning amount to the end amount. Well, when was the beginning amount? 1960. The end amount is 2012. So how long did it take to get from 70.5 to 41.4? It took 52 years, right? That's how long it is from 1960 to 2012. So your T is 52. Okay, now my first blank is what is K? So here's what I'm solving for. It's up in the exponent, so at some point I'm going to have to ln both sides to bring that out of the exponent. But before I do that, I can get rid of the 70.5 first by dividing by it. So I'm dividing by 70.5. Now remember, this is just like that first one where I'm going to just create a big math problem over here and type it in my calculator at the very end. So I cancel the 70.5 here. I still have E. Now I have negative K times 52. I'm just going to write that as negative 52K. On the left, I'm just going to keep this fraction going. 41.4 over 70.5. Now it's time to ln both sides to bring that negative 52K out of its exponent. I'm going to ln. Again, remember, you're just creating a big math problem over here. The whole reason I ln is because now on the right side, I can bring that negative 52K down. So now I have negative 52K times ln E. Now remember, ln E is just equal to 1, so that just says negative, oh, I forgot my case. So that really just says negative 52K times 1, so I don't even need that, right? Just bring this down. ln of 41.4 over 70.5. So what am I solving for? This K, which means I need to divide by negative 52. That will give me my K. Now, remember, when you type this in your calculator, the only part of this that you're taking the ln of is 41.4 over 70.5. So make sure you close out your ln after that 70.5. So ln 41.4 over 70.5, and then close it out, right? That's your numerator. Go ahead and hit enter. Now you should have negative 0.53233. You're going to divide that, so just hit divided by your denominator, which is negative 52. So there's your K. It says simplify your answer, round to 4 decimal places as needed. So 0.01023. So if I'm rounding to 4, I'll just stop after that 2. So 0.0102 is going to be your K. Now, the second part says M of T equals blank E to the blank T. So let's look at what that means. So here's where your blanks are. So in my formula, got the M of T, what's missing? The beginning amount. The beginning amount is 70.5 still. Now remember, what am I going to put in front of the K that I found? The K is 0.0102, but since we are decaying, I need to put negative 0.0102 T. So that's going to go in your second blanks. Then B says, estimate the percent of adults who are married in 2015 and 2018. So let's see, I'm going to write my formula up here. M of T equals 70.5 E to the negative 0.0102 T. So that's what this formula is. It says 2015 and 2018. It wants to know the percents that are going to be married. So here's my formula. Now I know the T, right? Because it told me the year. Now be careful. What does the T represent? The number of years after the starting time. So if it was in 1960, and now it wants to know the percent married in 2015, how many years has it been since we started? Let's see, 60 to 2000 would be 40 plus 15. So the T is going to be 55, right? So I'm finding M of 55. So I'm just replacing the T with 55. So I have 70.5 E to the negative 0.0102 times 55. And then seeing what that is. So I just typed that in my calculator, 70.5 E, so second ln. And then my exponent, negative 0.0102, open parenthesis 55, close. Round to 1 decimal places. So this is the percent of people married in 2015 is 40.22. If I round it to 1 decimal place, it'll just be 40.2. Okay? Now, 2018. So just 3 years after that. So now I'm finding M of 58. So let's see. I'm just changing that 55 to a 58. So 70.5 E to the negative 0.0102 times 58 this time for 2018. So I've got 70.5. Second ln to get your E. Now, your exponent's going to be the exact same thing as the last one, except that change that 55 to a 58. So negative 0.0102 times 58. Round it to 1 decimal place, so 39.01. So just 39.0, which is just 39. So 39% of adults will be married in 2018. All right, the last part of this question says, at this rate, In which year will the percent of adults who are married be 34%? So now I know this. I know 34%. What I don't know is the year, which is going to come from the T. So now, of this, do I know the end amount? Now I know the end amount is 34. What I don't know is this T. That's what I'm going to be solving for. I don't know what year it is. Okay, so I know the end amount is 34 equals 70.5 e to the negative 0.0102 t. I don't know the t. So again, just like the last couple of problems, we have a situation where we're solving for the variable in the exponent. So just like the last ones, I'm going to get rid of the 70.5 first by dividing by 70.5. So I still have e to the negative 0.0102 t equals, we're just going to keep this fraction like it is, 34 over 70.5. Now's the time to bring the exponent down, so we'll ln both sides. Now, this will come down. So now I have negative 0.0102 times ln e, which again is just 1, equals ln 34 over 70.5. So to get this, oh God, the t. So to get this t by itself, what's the last thing that needs to happen? I need to divide by negative 0.0102. So that's going to give me t. This all needs to go in your calculator. Now remember to close out your ln after that 70.5. So I've got ln 34 divided by 70.5. That's where you're going to close. Go ahead and hit enter. Now divide that answer. So divided by your denominator, which is negative 0.0102. And it wants us to round to the nearest whole number. So 71.4 would be just what? 71. Now, be careful of this question. What is it asking you for? At this decay rate, in which year? It wants to know, what is this year? Will 34% be married? Well, it's not the year 71. What does the T stand for? The number of years it took to get to 34%. So where did we start? We started at 1960, and it took me 71 years to get to 34%. So I just need to add this 71 to 1960 to see what year I'm at now, which would be 2031 would be the year. Okay. All right, number 6 is just a one question and part. It's not multi. Okay, there are currently 69 million cars in a certain country. So 69 million cars. Decreasing by 0.5% annually. So I know for sure the first thing I'm going to have to do to this percentage is turn it to a decimal. So move your decimal 2 places to the left and fill in the blank with a 0. So 0.005 is going to be your K, your rate. How many years will it take for this country to have 41 million cars? So I'm decreasing from 69 million to 41 million, and it wants to know how many years it's going to take me to do that. So if it's asking me how many years, what's my unknown in this? T. Anytime it's asking you about years, it's saying we're trying to find T. Which means, do you know the end amount? What was the end amount? 69 million cars was the beginning. 41, because remember, it said it was going down. So 41 million is your end. 69 million is your beginning. E. To the negative, right? So this K, I need to put a negative in front of it because we're decreasing 0.005 T. Solve it for T, just like I've done on the last couple of problems. So get rid of the 69 by dividing. So now I have 41 over 69 equals E to the negative 0.005 T. Now's the time to ln both sides to bring your exponent down. So what happens when I ln both sides? It brings my exponent down. So now I have negative 0.005 T times the ln E, which again is just 1. On the left, I just have ln 41 over 69. So to get the T by itself, what do I need to divide by? Negative 0.005. Negative 0.005. So once I do that, I'll know my answer. So ln 41 over 69, close it, enter, and then divide by your denominator. So divided by negative 0.005, round to the nearest year. So this one around it, so I have 104.1, which would just round to 104. It doesn't want to know what year it is. It wants to know how many years is it going to take. So you just leave that at 104, and it's multiple choice too. Okay, sorry, I know I want to